everybody. Welcome to Studio 64. My name's David, and I've been searching the interzones for some more science, space, and tech news to share with you. And I came across this at Popular Mechanics. Yes, apparently 5 hydrothermal vents have appeared in the dark heart of the ocean. Ooh. Very interesting indeed. And there's a good old hydrothermal vent, as we all know and love them. All right, let's see what they've got to say for themselves at Popular Mechanics. A research mission uncovered 5 new hydrothermal vents in a highly volcanic region of the eastern Pacific Ocean. Now, the vents spew fluids hotter than 570 degrees Fahrenheit and have appeared as a result of the East Pacific Rise tectonic plates continuing to split apart. Now, the use of both an undersea robot and a human-occupied submersible sped the discovery along. And this always fascinates me because this, I'm not a scientist myself, as I've said in previous videos. If there are any scientists out there that know more about this, please let me know. It'll be wonderful. Give your ideas in the comments below the video. But this is the sort of research that we can put into finding life on, say, the moons of Saturn or Jupiter. Can you imagine going to Enceladus? Quite possible. Definitely. Very interesting indeed. Expect intense heat on the floor of the eastern tropical Pacific Ocean. Researchers have learned that a location responsible for over 75% of the world's volcanic activity is more active than even previously believed, as they recently discovered 5 new hydrothermal vents, each spewing fluids more than 570 degrees Fahrenheit. Now, the team, led by Jill McDermott from Lehigh University, dipped 1.6 miles into the eastern Pacific Ocean, using both an autonomous underwater vehicle named Sentry and the human-occupied submersible Alvin, both operated by the Woods Hole Oceanographic Institution's National Deep Submergence Facility. The devices were used to track one of the most active thermal locations known at the East Pacific Rise near 10 degrees north latitude. Yes, and it's these little submersibles, well, not these ones directly, but the technology that came from good old Bob Ballard from the Woods Hole Oceanographic Institution in 1985 when he discovered the Titanic. These are the descendants of those little probes, and these little probes here will be the, shall we say, the forerunner of the probes that we will use when we go to moons like Enceladus, drop a heat sink down, go through the ice cap. Never know what you'll find under there. And little probes that will be, as I said, the new technology of Alvin, or Sentry will be what we'll see up there in space. But let's have a look here and see what else they've got to say for themselves. It is dotted with thousands of deep-sea hot springs like these, which altogether extract 10% of the Earth's total internal heat. Thibaut Bareve, I'm sorry, Thibaut, if I've mispronounced your name there, co-lead scientist on the expedition, said in a statement, "We want to increase our understanding of how hydrothermal vents release heat and chemicals as they flow through the seafloor and affect the global ocean." Now, the find of these hotter-than-hot vents came as a result of a collaboration between humans and a robot. Each night, the crew sent the robot Sentry to scan high-resolution maps with its sensors. When the robot was retrieved in the morning, the researchers planned how to use the human-occupied Alvin to better investigate locations that could prove valuable. Well, it makes sense. Send the robot down there, find out the places that would be worth investigating, and ignore the ones that humans, there's no point going there. That makes perfect sense. Much more efficient, definitely. Now, the high-resolution maps from Sentry allow us to spot likely new hydrothermal fields as soon after Sentry comes back on deck, McDermott said in a statement. This gives us great targets for Alvin and the opportunity to make multiple discoveries in a single dive. Now, the East Pacific Rise, part of the globe-spanning mid-ocean volcanic mountain ridge chain, has 2 tectonic plates splitting apart at over 4 inches per year, making it a prime research location. But getting Alvin there was a key piece of the equation. Alvin has proven critical in discovering hydrothermal vents since it first started exploring an oceanic spreading ridge north of the Galapagos Islands in 1977. Wow, hard to believe that Alvin's been at it for nearly 40 years. He must be very tired. Yeah, but seriously, that's just incredible, isn't it? With chemical-rich venting helping to supply energy to animal life and create a diverse ecosystem in the waters around the vents, the researchers say that understanding more about these underwater vents can give researchers key tools in searching for potential life-supporting environments throughout the universe. Exactly what I was saying before. Plus, if we ever build undersea bases, like all the science fiction I saw when I was a kid with, Sequest 2020 and all this sort of thing, we could use these thermal vents as a heat source, quite possibly. And again, we go out into space eventually and we start colonizing these moons. You never know. We could use the, if there's thermal vents down there, we could use them as a heat source. Fascinating. Daniel Fornari, a co-lead scientist on the expedition from the Woods Hole Oceanographic Institute, said the Sentry mapping provides important details of lava flows that erupt in deep ocean. Very, very incredible. As I said, I love all science. It gets me down in my nerdy nether regions. Then again, my personal life is no concern of yours. Yes. That allows them to target ideal locations for collecting rock samples. These new perspectives and the analysis of rock samples will let us figure out how quickly the lava erupted, how far it travels, and the impacts deep-sea lava eruptions have on hydrothermal venting, he said in a statement. Now, this wasn't the last time Sentry and Alvin will team up to explore the East Pacific Rise. A follow-up expedition aims to discover more distinct geophysical, chemical, and biological processes. It just may show even more hydrothermal venting from one of Earth's most intense volcanic locations. Absolutely amazing. As I say, I love all this stuff. As I said, it's not just valuable for Earth and looking after our own ecosystem, but things we could learn in the future for possible power generation, and also researching for when we travel out into space is absolutely amazing. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space, and Tech News Update. I shall see you on the next one. If you enjoyed this video, please like, share, subscribe. I greatly appreciate it. If you're up for it, drop a comment down below the video because I'd love to hear what you think. All right, take care. And as I always say, if you can't be good at it. And as I also always say,
my brain hurts!